So here we are, September 22nd, 2016. This is my fall equinox. So at the Google search, I did Austin fall equinox. I'm going to go to timeanddate.com again. I'm going to scroll down here. And you'll see the September equinox is September 22nd, 9:21 a.m. here in Austin. So I want to show you what timeanddate.com has to say as far as what I'm supposed to expect to see for a sunrise angle and sunrise sunset here in Austin. I'll scroll down here. Here we are at the 22nd. And the sun was supposed to rise at 89 degrees at 7:20 a.m. And it's supposed to set at 270 degrees, 7:27 p.m. You can see the 23rd looks like a little better equinox with it rising 90 degrees, setting 270, but it said that the 22nd is the equinox for me. The footage I shot this morning of the sunrise on the equinox was shot right from this location. Now this is Google Maps Street View. I have it set up so that we're pointing right at the direction. You'll see in just a second that the sun rose right here. Okay, so notice these three electrical towers. We got the big one here, and then they're going off in the distance like this. You'll see that in just a second. Now I just want to show you Google Earth. I've got some pins located on here, the filming location. This is from the street view. This is where I was sitting when I was filming the sunrise this morning. And then from the Google Street View, these were the two smaller electrical poles. And then this is the larger electrical pole that's off in the distance. So what I'm going to do now is I'm going to pull out the ruler and I'm going to extend a line from the filming location just off to the right side of that smaller electrical pole. Now I'm out at the distance of that large electrical pole. You'll see that the footage that I shot is just like this. This gives a heading of 93.32 degrees and a distance of 1.26 miles out to those large electrical poles. So the way I recorded this morning was as I set a compass on top of my Nikon P900. I used my phone to record the angle that the sun was coming up, but at the same time I had the P900 recording the sunrise as well. Now I did come up with a little bit of a discrepancy as far as the angle that the sun came up, but you're going to see in just a little bit that it's what the P900 that captured that's going to give us definitive proof that we're in a simulation. So here we are back at Google researching distance to the horizon. And you can see that the official answer is for an observer on the ground with eye level at height 5'7". The horizon is at a distance of 2.9 miles. For an observer standing on a hill or tower 100 feet in height, the horizon is at a distance of 12.2 miles. We're going to go down here to this calculator. You know, it says this is a rough guide. And that's all we need right now. My camera was on a tripod. It was on the back of my truck. So I'm going to say that we were 9 feet high above the ground, all right? So the calculated distance to the horizon is 3.7 miles. That's not a big deal. I'm going to show you something else. Another thing that we need to consider is visibility. So we're back here at Google doing a little research. We've got visibility distance in here. This first answer is about the horizon. The second one, visibility, Wikipedia. We want to check this out. Now you can read this all yourself, but it's a meteorological term. There's definitions for it. There's calculations for how it's decided. You can see that they have specific definitions. For visibility less than a certain amount, it's considered fog, or less than this, it's mist, or less than that, it's haze. So visibility is something that we can actually check out on our different weather sites. Let's check it out. So here we are at Weather Underground, and they do show what the visibility is, and it's 10 miles. All right, we've got clouds, a few scattered at 4,800 feet, scattered clouds at 7,000 feet. Look at visibility here. The greatest distance toward the horizon at which prominent objects can be identified with the naked eye. All right, so we are limited in our visibility. This is very important to consider. So as you're watching this, I want you to consider the things that we just touched on. Visibility is 10 miles. Distance to the horizon at 9 feet, 3.7 miles. Those electrical towers, 1.26 miles. How far are those clouds from me while I'm filming? I mean, they're not more than 10 miles, right? Well, watch this. Let's watch as the sun penetrates this layer of clouds right above it. You might be thinking to yourself, oh no, it's not going to go through that next layer too, is it? Oh yeah. Yeah, it's going to come out of the first layer. It's going to go through the second layer too. So this isn't the first time I've filmed the sunrise up through the clouds like that. I have this video Flat Earth Sunrise compilation in St. Martin with clouds and birds behind the sun, where I captured as well. I published this May 4th of this year, and you just take a peek here. It's the same type of thing where the sun came right up through the clouds. It's incredible. I've got a number of these sunrises like this. The only thing is I didn't understand it back then like I do now. So we'll draw those connections. So to make the connections, I want to bring you back to Google Earth here. This is the map that we're using before as far as the way I was shooting this video. You can see that north was set to the west here. We're going to spin that back up to the north. And we're going to zoom out a bunch. And now we're going to pull out our ruler. I'm just going to show you that from that filming location, we're at like around there so here's 13 miles. Visibility is 10. So I can't see that far. It's impossible. How far were those clouds? They were definitely less than 13 miles. My camera can't see that far. Okay, so where did the sun come from? Somewhere in here the sun rose. It came up like a hot air balloon through the clouds. It didn't come up over the horizon. I mean, take a look at this. Where did the sun come from? I can't see out here. You think it rose in Houston? I can't see that far. No, it came up probably about 10 miles away from me. Somewhere out in this range. It came through the clouds. It's going to take 12 hours to go over my head. And 10 miles over here, it's going to disappear again. Think about that. It's a simulation. From wherever you are out here, it's going to come up 10 miles to one side of you. It's going to take its 12-hour trip or whatever, and then it's going to go down 10 miles on the other side. And this depends on visibility, but that's how it's working. I continue to pray fervently to the Creator of this world to reveal the truth. And when I started making this video series, The Definitive Proofs, I knew that I had evidence that we're not on a ball and that flat earth maps don't work, but I was going to have to connect lots and lots of dots for the definitive proof that we're in a simulation. But now today, when I went out to film the equinox, the clouds were absolutely perfect to show me that the sun was coming up locally, very close to me, specific to my location. And I had photographic proof. This is something that everybody can do. You can do it. You just need a long range, telephoto lens, telescope, get whatever equipment you want, and start filming sunrises and sunsets and analyzing them. And if you continue to pray and ask the Creator for the truth, you'll get a situation where the clouds are lined up right, or something shows up when you're recording, that it'll show you that it's local and it's close. So I'm going to continue to put out videos in this series. I've got all the rest of the footage, I condensed it so that this video wouldn't be too long. I'll put all the footage together at regular speed in a video and put it up so everybody can take a look at it and analyze it, and I recommend that you go out and do your own. Till next time.